All right, here we go. So for today, this could be real quick if we can get everybody on the same page here and kind of just go hard in the paint and focus. I think I can get you working on stuff here pretty quick. So click and closed. Focus up here, please. I'll be as quick as possible as I can possibly get through this. We're going to talk about evaluating functions. This is going to go quickly because it's stuff we've already kind of done a little bit without really calling it that. It's stuff that we've already done. So some notes. So this is page 2 of your notes. Function notation. I'm sure that you've had teachers in the past. I'm sure that, Mr. Morioka or Mr. Hagewood said something like this. F of x is just a fancy way of saying y. They mean the same thing. They're interchangeable, right? They're just two different notations. Just like we can write when we solve absolute value inequalities. We can write our answer using compound inequalities and get the correct answer, and that's fine. Or we could write it using interval notation. And they're the same answers, just different notation. Two different ways of saying the same thing. Okay, why do we use function notation? Well, the main reason we use function notation is so we can evaluate functions. Okay, what's that mean? We're just going to plug numbers in and figure out what the output is, right? So when we write a function like this using function notation, x is the input. X is always the input, right? X is the input and the output is f of x. Normally we would say y is the output, but in this case we're replacing it with f of x. Okay, this is handy when we want to do things like this, where if we're given a function and we want to, like say we're told f of x equals 2x plus 7, and we want to find this. What is that? Here, I'll write it bigger. How would I say that? Somebody want to take a stab at that? Say, how would I say what I wrote in purple there? No. Like if I were just gonna read that, what do you think, Addie? That's it, f of negative 3, okay? It's f of negative 3, just like this is f of x. When I write a function down with function notation, remember, this does not mean f times x, right? Because sometimes, like when we put stuff next to, outside of parentheses, in certain situations in math, that means you're just multiplying, but it does not mean that here. This means that this is some function f with an input of x. When we say f of x, that's really what we're saying, okay? So down here, when we say f of negative 3, that just means that we're plugging in an input value of negative 3. What that's really shorthand for, like if I were to say the whole sentence that f of negative 3 stands for, I would say the value of the function f when I input negative 3. That's what we mean by f of negative 3. So how do we calculate that? Well, this is the same stuff we did in Unit 1 when we were evaluating expressions. We didn't have function notation then, but we still did some evaluating, right? What did we do? What was the rule? Every place where we had a variable, we plugged in a set of parentheses, an empty quantity that we could dump the value into, right? Same thing here, exact same thing. Where I used to have an x, now I'm going to replace that with the quantity negative 3 and just simplify. Well, 2 times negative 3 is negative 6 plus 7 is 1, right? So then this corresponds to the ordered pair negative 3, 1, right? The input is negative 3 and the output is 1. Okay? So really what that means in terms of a graph, if I were to graph this line then, or this line, same line, that just tells me that the ordered pair negative 3, 1 corresponds to a point that would be on the graph of that line, right? Okay, give me 1 to 5, everybody. How we doing? Okay? All right. So let's just practice this a little bit, and it's really simple. It's really simple. If we want to, in number 2, I want to calculate f of 3/10, where here's f of x, it's defined for us. What am I doing? I'm not solving. I know you mean the right thing, but the solving is something different. We're evaluating, right? But how do I do that? What am I going to... Okay, I'm just plugging in where I used to have an x. I'm plugging in the quantity 3/10, right? And then I just simplify. So negative 5 times 3/10 is negative 15/10, right? Which is negative 3/2. Negative 3/2 minus 14, I'd have to add some fractions there. But if I did that math, I'd get negative 31/2. Okay? I'm going to show you how you can do this more quickly and easily on Desmos. So why don't you get out your Chromebooks and just go through this with me. Open up Desmos. Okay, it doesn't matter for this one if you're using Desmos graphing or scientific, makes no difference. We're going to do the same thing. Right? If I want to evaluate this function, what do? We did this when we were checking solutions for absolute value equations, right? I have to define the function. So I'm going to type in, what f of x is equal to, negative 5x minus 14. And think what we're really telling Desmos here, or the math gods. We're just giving them a rule to follow. It's telling them how to treat the inputs. It's just saying that when we input something, we're going to multiply that by negative 5, and after that, we're going to subtract 14. That's all that's telling them, right? So there's the rule to follow when we input values. And then I just want to figure out what the output is when I input 3/10. So what am I going to type right below that on the next line? What am I going to type there to get that answer? Not f of x. F of 3/10, right? I already defined what f of x is. Now I want to do f of 3/10, and look what it tells me. If I turn that into a fraction, negative 31/2, just like we got when we did the algebra, right? Okay, so Desmos makes that really a simple process, right? Okay, let's go back. What about g of 0.4? Well, here's g of x. G of x is negative x squared plus 9x minus 1. So what's g of 0.4 going to be? How am I going to do that? And just for a second, I'm going to let you do it on Desmos in just a second, but let's try it once. I want you to tell me what I would do with that if I weren't using Desmos. What would I do there? Okay, but it's not f, it's g. Okay, so every place I have an x, in g of x up here, there are two x's that show up, right? I've got a negative x squared plus 9x minus 1. Every place I have an x, I'm replacing it with the quantity 0.4, right? That's it. So I have 0.4 squared. I'm going to make it negative by multiplying by negative 1. Now, I do want you to notice one thing here, because this is a very common mistake. A lot of times people want to do negative 0.4 squared, but that's not it. It's negative x squared. So by order of operations, first I have to square whatever x is, exponents first, then I multiply by the negative, right? So the negative is going to be in front of the 0.4 in parentheses that's being squared. Everybody get that? And if I do all that math, negative the quantity 0.4 squared plus 9 times 0.4 minus 1. If I crunch all those numbers, I get 2.44. Now let's see you get it using Desmos. Everybody real quick, before you get too settled in, go up and grab one of those slates up there and get a dry erase pen. more markers? Yeah. Oh, there's some extras. Here's a couple extras over there. It's not working? Okay. That makes sense.
He can't make shots or nothing. He's always like that. I carry him on 2K.
Is that true?
Yeah, he's a wannabe shooter. That's what he is. I'm the only Tyson, I carry you.
There you go. 4, all right. There you go.
Oh!
All right. There you go. There you go. There you go. Oh.
I need one more.
Okay. There you go. Okay, so to get where'd that go? Okay, so was everybody able to get 2.44 on Desmos for that one? Okay, try it real quick. We're going to, there's g of x, right? And we're going to evaluate it at 0.4. Okay, we're good with that? Okay, we're going to have a little race now. We're having a little Desmos race. Okay. Number 7, go. When you're done, write the answer on your whiteboard and hold it up. Whoops, sorry. You think you got it? Let's see it. That's it. That's it. No. Okay, hold it up when you got it. There it is. There it is. Okay, turn it into a fraction. Oh, and that's not it anyway. No. Yes, must it. Now you're just using Desmos, right? You don't have to do the math. Just use Desmos. We're doing number 7. Maybe some of you typed in the wrong function. Maybe you typed in Q instead of P or something. That's probably it. There it is. Okay, hold up that board when you got it. Did you get it, Cooper? There it is. There it is. Just reduce it, yep. Okay, but you must not have used Desmos, right? Because it would have reduced it for you. But when you put it in, did you put it in Desmos, Leo? Practice. I want you guys. I mean, you probably did it like actually adding the fractions up and everything, which is good. But I want to see if you guys. I want you to practice using Desmos. That's it. Yep. That's it. There it is. Okay, so here's what it should look like on Desmos. Okay, there's what number 7 should look like on Desmos, right? Good? I'll put it up here. Okay, there's number 7. Right, all I have to do is I have to define the function in Desmos and then evaluate it. Okay, everybody try number 9. Try number 9. What is that? -2? Is that what it is?
Oh, wait, no, I got 2.
2 is correct, yeah. That's not what you had written, -2 down though. There it is. Okay, absolute value. Yeah, and it's right below backspace. If you hit shift, that vertical line, that's it. Yep. That's it. It is, but you just got to click the fraction bar. There you go. Yep, that's it. No. Not it. See what you did? Oh, there you go. that would explain it. Okay. So you should get 2, right? Yep.
I got it.
Good. Good, good. Okay, moving on. Moving on. Put the boards down for a second now. So let's take a look here at, what if you do a problem like number 11? Okay. Number 11, they define P of x and Q of x, and they want us to simplify 7 minus Q of 4.5. So what is Q of 4.5? Everybody click them close. You have to click them all the way, but click them down where they're not going to distract you. What is Q of 4.5? What's that mean? How do we interpret that? It's what? Well, no, I want to know what is Q of 4.5. I know 4.5 is 4.5, but what do we mean by Q of 4.5? Oh, okay, so it's, say it again? No, it's not times. Look, Q of x is a function, right? So when we see something like this, it does not mean Q times 4.5. It means Q of 4.5. What is that? Okay, it's part of an ordered pair, isn't it? Right? It's the output, right? Everybody with me? Okay, and so when we see something like that, it's just an output number. That's all it is. When we input 4.5, Q of 4.5 is just an output number. That's all it is. Just a fancy name for a number, just like the symbol pi stands for a number, right? It just stands for a number. So how would I do this problem then? Number 11. Let's say without Desmos. Okay, first thing I would do is I got to figure out what is the output number. So I would plug 4.5 in for x into q, right? And if I did that, I get the absolute value of 3 times 4.5 minus 4.5 cubed. I'm just going to simplify this using PEMDAS, right? So I have to simplify everything inside the absolute values first, inside the grouping symbols, right? So 3 times 4.5 would give me 13.5. 4.5 cubed is 91.125. I'm going to subtract those two things and get a negative answer, right? I'm going to end up getting, there's one step that they skipped that I'm going to write. So that's equal to the absolute value. If I take all that stuff, 13.5 minus 91.125, I get negative 77.625. And then I take the absolute value of that negative, and that's my output. Am I done? What do I do? Oh, okay, then I have to subtract that from 7. Because all we did there was we just found what the output number Q of 4.5 was. Now we have to finish the problem here by subtracting that from 7. Right? So that's what we get. Okay, now on Desmos, see if you can get that real quick. Okay, done. I'm super fast typer, I guess, huh? I already had Q in there. You probably do too. Oh, man, get out of there. Okay, so look how easy it is. Look, all I had to do on Desmos was just define the function and just type out that expression. Desmos will tell me, because Desmos knows that Q of 4.5 is just a number that it's going to generate from that function. So it's going to do 7 minus whatever that number is that it calculates and give me an answer. I don't even have to separate it into steps. I just enter the function and then evaluate the expression. Anybody see that? Okay, give me 1 to 5. Okay. All right. Okay, something different. What about something like this now? How am I going to do number 13? Am I putting 34 in for x? Thumbs up, thumbs down. Do I put 34 in for x? Okay, that's thumbs down, isn't it? That's not what I'm doing. What am I doing? Okay. Okay, good. So what I'm trying to do, I'm setting the function f of x, which is 3x plus 19, equal to 34, right? And solving from there. Right, so here's my f of x. 3x plus 19 is equal to 34. We want to know when the output y is equal to 34, not when the input is 34. We're trying to find the input that goes with that output, right? How would I do that? How would I ask the math gods for the value of x here? Solve it. Just solve the equation, right? Subtract 19. And I get 3x equals 15. So what's x? 5. Divide by 3. X equals 5. Okay? So we could do the same thing here with number 14. But I want to show you how you could use Desmos to do this problem. And that's not hard to do. But this would be a much harder problem if f of x were some kind of bizarre radical, or if it were some weird exponential or logarithmic function like that. Then it might be tougher to solve this algebraically, right? And that's where Desmos would really come in handy. So click and close and take a look, please. So when we're solving a function for a value, when we're setting a function equal to a value and solving, here's how we can go about that. So now, by the way, you have to be in Desmos graphing for this. This is not a Desmos scientific issue. It can't help you. You got to be in Desmos graphing for this. So I'm going to first of all enter the function, and look, it gives me a graph. Okay, so let's just stop there for a second. Let's not even go to the other part of this yet. There's my graph of f of x. Okay. How do you think I could, for example, how do you think I could plot a point in Desmos at x equals 2, y equals 4? What could I type in row 2 to plot a point? What do you think, Brock? What do you guess you probably would type there if I want to plot a point? Okay, ordered pair 2, 4. Yeah, so I got to put it in parentheses because it's an ordered pair. 2, comma 4. What do you know? Look at that. If I click the label box, it even labels the point with its coordinates. Okay, pretty amazing. If I change this x value to 6, it moves the point. Okay? All right, so now my next challenge for you is I want to find the point on the red line with the that has an x coordinate of -6. How could I do that? I want to be able to put a point on my nice red line there where x is -6. -6, 0. Okay, let's try it. -6, 0. Ah, we missed. 0, -6. Okay, let's try that. No, I missed it again. I want x to be -6, right? Yeah, but I got to figure out the y value. What's the y value going to be? What's it going to be? Okay, we can probably see it's going to be 1, right? But what if it wasn't so easy? What if I want to do a value like, oh, I don't know, like how about -5.7 or something, right? Then how am I going to know, right? So let's make it trickier. -5.7. Now I missed it. How am I going to get the y value that goes with -5.7? I got Desmos up here at my disposal. I can use it any way I want to. Yeah, I can't have it do that. I got to find the y value on my red line when x is -5.7. How would I do that? You guys know, you know how to do it right now. You just got to put the thoughts together. Leo, you got an idea? You could, but that's going to be an estimate. I want an exact value. Desmos will tell me if I just ask it. Addie, what am I going to do? Yeah, just put that into the function, right? Let's evaluate the function at -5.7. Well, there's the answer. It's 1.9, right? So that means I can go down here and I can do -5.7, +1.9, and what do you know? I'm right on the line, okay? Did I even really have to go through that step? No, I didn't. I didn't even have to use row 2. I can delete row 2 and still get that answer. I could go down here and tell Desmos, I just want the output of the function when x is -5.7. So I could just plug in f of -5.7 right there, and look what it does. Do you grasp what it's doing there? You got to put on your thinking caps and really kind of contemplate this a little bit, right? You're using Desmos's ability, and Desmos is, I tell you what, it's kind of a good thing. It's a good thing to mess around with because, as somebody who's done a lot of programming, it's like programming. And so, you know, when you go to college, everyone's going to need to do some coding in college. It's just, that's part of, if you're going into, unless you take no math classes or science classes, but I would say the majority of people will, probably everybody, will be required to do some coding. And this kind of gets you ready for it a little bit. Okay? Next question then. different question. How am I going to figure out now? It was easy to do that last case, right? The last case, finding the y value when I have the function, if I know the x value is a piece of cake, I just plug it in the function, done. This is the opposite though. How am I going to use Desmos to find the x value when y equals negative 62? Okay, I'm hearing, say it again. Go ahead, yeah. Plug in negative 62? Okay, so where am I putting the negative 62? Okay, so if I do, does everybody see here, like if I just do f of negative 62, then I get a huge number and I have to zoom way out to see this if I make a point out of that. But if I zoom out far enough, I can see it there. Right, there's my point. X is negative 62, y is negative 167. I don't know if that's what you're saying, but that's not what I want, is it? What's the y coordinate of that point? What's the y coordinate of that point? Austin, what's the y coordinate of that point? No. Negative 167, because that's the output I got when I input negative 162. That's not what we're being asked to find, though. We're trying to find the value of x when y equals negative 62. Okay, what happens if I just graph the line y equals negative 62? Let's try this. So there's the blue line, y equals negative 62. Okay? What's the y coordinate of every single point on that blue line? Negative 62, right? So what's going to be the y coordinate of the intersection of those two? Negative 62. Okay. Isn't that the point we're looking for? Isn't that the point on the red line with a y coordinate of negative 62? Okay, so what's the answer? What's the x coordinate that goes with it? Negative 27. What do you know? What do you know? There's the technique you'd use in Desmos. If I want to know when a function equals a certain number, I just graph, I graph a horizontal line that has that value and I look for the intersection. So just y equals negative 62 and the solution is negative 27, just like we found right there when we did the algebra. Everybody see that? Okay. This is a great trick. It's not really a trick. This is a great method for solving any equation. You can solve any equation graphically this way, right? Sometimes equations are very difficult to solve algebraically, and this is how people would do it. They would just solve it graphically in those cases. Okay? All right. Last issue. So what about this stuff? Now, if f of x is negative 4x plus 9. Okay, you guys, I want you to do a couple things for me here. F of x is negative 4x plus 9. What is f of 1? How do I find it? What's f of 1? Cooper, what's f of 1? Okay, negative 4 times 1 plus 9. In this case, I can simplify that, right? I get negative 4 plus 9 equals 5. What is f of b? What's f of b? That's it. That's my answer. How come? Because I follow the rule. It just told me to plug in a b for x. Can I simplify that anymore? I can't, so I'm stuck. That's my answer, right? What's f of hand? Well, f of hand would just be negative 4 times hand plus 9. So whatever's behind my hand would just be there, right? So in that case, what's f of c plus 2? What's f of c plus 2? What do you think? Yeah, negative 4. Whoops. Negative 4 times the quantity c plus 2 plus 9. That's it. Now, I could simplify that a little bit, right? I could distribute the negative 4 and get negative 4c minus 8 plus 9, combine like terms, and that's my answer. Okay, it's got c's in it, but that's okay, right? I mean, we can't get rid of the c's because we don't know what c is. Okay, but that's the answer that we get, right? If I, like on number 19, if I want to do g of a minus 3, well, then I would just be plugging a minus 3 in for x, and I'm going to get the quantity a minus 3 squared minus 5. Now, real quick, this is a big mistake people make. Is a minus 3 squared equal to a squared minus 9? Thumbs up, thumbs down. Okay, I'm seeing a mixed bag here. The answer is no, it is not. Okay, so is it a squared plus 9? The answer is still no. Still no. What does it mean to square something? I'll multiply it by itself, right? So if I want to figure out what a minus 3 squared is, I have to simplify a minus 3 times a minus 3. I have to distribute that out, FOIL that out, right? Okay, so if I do this problem then, a minus 3 squared, if I FOIL that out, I'm going to get a squared minus 3a, distribute the negative 3, I get another minus 3a plus 9. So when I add up the like terms, I get a squared minus 6a plus 9 minus 5. That's my answer, right? Okay, last one and I'm done. And then tomorrow you guys get a work day, maybe a little bit today. What about this guy? What about this guy? Do I have, yeah. Number 20. Okay, that one's a little tricky, right? We're going to have to figure out g of 2m plus 1 is going to be some weird kind of output. I'm going to have to do something like I did up here in 19, right? I'm going to have to input 2m plus 1, that quantity, into g. So does everybody see then that this is going to give me the quantity 2m plus 1 squared minus 5? Give me thumbs on that. Because this is g of x. G of x is x squared minus 5. So g of the quantity 2m plus 1 is the quantity 2m plus 1 squared minus 5. Right? And I'm going to have to simplify that. Minus, what is f of 3m minus 7? Well, there's f of x. So it's going to be negative 4 times the quantity 3m minus 7 plus 9. And I've got to put that whole thing in brackets, right? Because I'm subtracting the whole thing. Everybody get that? Okay. So I'd have a little work to do there, wouldn't I? Okay? All right. We won't finish it, but just want to point that out. Okay. Good job.